Mahamanav Aerospace and Research Exploration Private Limited. This is an internship program on avionics presented by Priyanka Ayali. Lightning system. In this module, we are going to study about the introduction, VASI system and PAPI system. Approach lighting system. An approach lighting system ALS is a lighting system installed on the approach of the end of the airport runway and consisting of series of light bars, strobe lights or a combination of two that extends outward from the runway end. ALS usually serves a runway that has an instrument approach procedure IAP associated with it and allows the pilot to visually identify the runway environment and align the aircraft with the runway upon arriving at a prescribed point on an approach. Modern approach lighting systems are highly complex in their design and significantly enhance the safety of the aircraft operation, particularly in condition of reduced visibility. Operation. The required minimum visibility for an instrument approach is influenced by the presence of type of approach lighting system. In the US, a CAT ILS approach without approach lighting will have a minimum required visibility of 3 by 4 mile or 4000 foot runway visual range. With a 1400 foot or a longer approach lighting system, the minimum potential visibility might be reduced to half mile 2400 visual range, and presence of touchdown zone and centerline lights with a suitable approach lighting system might further reduce with a visibility of 3 by 8 mile 1800 feet runway visual range. The runway lighting is controlled by the air traffic control tower, and at a non-towered airport, pilot controlled lighting may be installed that can be switched on by the pilot via radio. In both cases, the brightness of the lights can be adjusted for a day and night operation. Depth perception is an inoperative at distances usually involved in flying aircraft, and so the position and distance of runway with respect to an aircraft must be judged by a pilot using only two-dimensional cues such as perspective as well as angular size and movement within the visual field. Approach lighting system provide additional cues that bear an own relationship with the runway itself and help pilots to judge distance and alignment for landing. Decision bar. All approach lighting systems in the US utilize a feature called as a decision bar. These are always located 1000 feet away from the threshold in the direction of arriving aircraft and serve as a visible horizon to ease the transition from instrument flight to visual flight. An approach lighting system are designed to allow the pilot to quickly and positively identify visibility distance in instrument meteorological condition. For example, if the aircraft is at the middle marker is located 3600 feet from the threshold. Decision bar is 2600 feet ahead. If the procedure calls for at least half of the statute mile flight visibility, roughly 2600 feet, spotting the decision bar at marker would indicate enough flight visibility to continue the procedure. In addition, the shorter bar before the after the decision bar are spaced either 100 feet or 200 feet apart depending on the ALS type. The number of short bars the pilot can see can be used to determine flight visibility. Approaches with lower minimum use the more precise 100-foot spacing system for more accurate identification of visibility. A PAPI and VASI are very similar in the information they provide. The only functional difference between VASI and PAPI is that the VASI has the red over the white, and PAPI, the white actually goes to the right of the red, and the PAPI offers higher precision or more glide slope depending on how you look at. A larger airliner with a high cockpit may elect to fly slightly higher glide path. The concept is same though. Have a look at this diagram of PAPI and VASI. A regular VASI only offers one glide slope and is designed for an aircraft where the cockpit isn't so high up. However, there is such a thing as two light PAPI and 3-bar VASI, so either of them can be easily tailored to fit the cost and types of aircraft flying to the airport. In case of a 4-bar PAPI, it is higher precision. Since the PAPI system uses a narrower beam of the light, you must fly the glide path more precisely than the VASI to stay on the beam. The PAPI with its extra light forewarns when you are drifting from the desired glide path. So, one red light would indicate slightly above the glide slope, 2 and 2 would be indicating normal glide slope, and 3 red light would indicate slightly below the glide slope on the 4-bar PAPI. A 3-bar VASI works in similar fashion except there are only 2 glide paths with 2 reds being the lower, 2 whites being the higher. A typical visual approach slope indicator VSI uses a four set of two lamps in a box formation, two on top, two on bottom, to provide something more like a three distinct set of information. Operation. As far as the operation and installation goes, I am under the impression that both use the same two lamp module configured with lenses, reflectors and filters. Presumably the cost of all install a VASI is lower, which is why they are much more common. Alignment and maintenance is also likely to be cheaper as well. Furthermore, if one set of lamp is in PAPI is out of service, the entire unit is unusable. If a set of lamp is in a VASI is out, the redundancy of a system means that it still can provide some information. This was all about the lighting system. Thank you.